Hi everyone, welcome to my channel. This is Awada. This will be a series of training and tutorials on applying machine learning for biomedical data and neuroscience-based data sets like EEG, fMRI data, structural data, genetics, and so on. So I note there's a lack of covering of biomedical data uh, from the perspective of machine learning. So I try to use machine learning methods and algorithms on biomedical data. This does not mean that you cannot take this knowledge to any other data set. Uh, but what I'm trying really to do is to simplify knowledge from machine learning perspective to other to biomedical data, basically. I'll be covering many topics like classification, regression, clustering, feature selection, ensemble methods, deep learning. I'll be using R for the time being. Also, I'll be using Python for certain applications. So it will be more application for machine learning. I will not go in depth in the theoretical side. I will be covering the tools and the methods and certain tools. I'll be describing these tools in a more general way, where it can be directly taken to other applications. So today I'll be using Caret package. Caret package is one of the nicest packages for doing machine learning in R. Uh, Basically, Caret package is a wrapper around many machine learning methods. Also, it includes many helping functions to run your machine learning methods. So you don't have to write your own training procedure for your data. You don't have to write your own methods to define your metrics or and so on. So it has all these set of information or tools to apply machine learning on these methods. As I told you, Caret is rather around many machine learning methods, and if you can look at their GitHub page, they tell you the list of machine learning methods that they support. Basically, there are more than 238 machine learning methods they support. Uh, what you have to do is, for example, if you decided to use AdaBoost, so you have to install the corresponding library. Also, you have to worry about the tuning parameters, uh, what kind of methods that can be or problem that can be used to for. For example, here AdaBoost can be used for classification. Some methods can be used for classification and regression. Again, you have to worry about the dependencies in terms of uh, R packages. The second thing that I'm going to use is the machine learning bench library, which has many data sets for machine learning. So you can load them directly. You can look at this package and see the list of data sets that are available. Also, I'll be using the Caret ensemble, which is another wrapper around Caret, which again can simplify training by allowing ensemble methods across machine learning algorithms. I will have a separate video about that. Uh, but also it allows you to train several methods or several machine learning methods at the same time. So assuming you have installed the three datasets or the three packages, let's load them. The first thing that I'm going to use here is loading dataset. I'm going to use the Sonar dataset. Sonar dataset has over 208 samples with 61 columns. The last column is the class column, and it has two values, R and M. So this will be our problem for today. I will not focus a lot on the data set. Next thing, I will be using the configuration, how I'm going to proceed with the training. You can set that by using train control. If you look at the help of train control, it has several options. The first option, the kind of validation they are going to apply in your dataset. In this example, I'm going to use cross-validation. You can look at the list of available options. You have repeated cross-validation. You have some other options. You have, for example, leave one sample out, which is can be used for specific application. The next parameter is the number, which is the number of all the cross-validation that you are going to use. In this case, I'm going to use 5. You can use your own number. You want also to store your final predictions after optimizing each method or each fault of the cross-validation. Another thing you want to set is the index. Index is a way that you mark your samples, whether they were training or testing in each fault. This is nice if you later want to access your data or like do some predictions out of sample prediction from your data set. And this, for doing indexing, there's already a function in Caret called Caret resample, and you give it one variable from your data set and the number of faults, so that you tell Caret to use specific indexing for your problem. Also, you want to set your seed. This is important if you want to reproduce the same result on the same machine. After running this, you have set up your training procedure. The next thing you want to use Caret list. Caret list comes from Caret ensemble. It's another wrapper around Caret. With Caret list, you give it your training problem as a formula. So you want your response is class as a function of the data. So here I'm going to use all columns or features in our data set. Then you can specify your pre-processing, so which is one of the nice things you can apply with Caret. You can specify what kind of pre-processing you want to apply for your data set. For example, here I'm going to scale and center all columns in my data set. You can easily add applying PCA, and Caret package will take care of doing the applying PCA on your training data in each fold and apply it to the testing set. You don't have to worry about the transformation. It can be done automatically by Caret. Another thing you can apply here is sort of computation for netting data. There are other options. I'll be covering these options in another video. After that, you can specify your method list. So here I'm going to use GLM and KNN. You can easily take any of these algorithms here and plug it in here as far as you want, and as long as you install your corresponding packages. So if I run it here, then it will go over my data and run it in a 5-fold cross-validation, and then I can look at the correlation of the outcome between each method. You want to see whether each method is performing similarly to other methods. This is important if you decided later to combine the outcome from different methods in one ensemble method. Also, you can look at the summaries. You can look at the accuracies of your classification, and you can look at the some statistics of the information. You can here in your train control function, you can specify what kind of metrics. If you decide to use ROC as your metric, you can specify it here. This is also can be easily adjusted in your algorithm. So let's say if you want to add random forest, and maybe FPM with radial function. So if you run it in this way, you can easily adding two other machine learning methods right away to your model, list of models. Again, you can look at the correlation across your methods. You can see here GLMNet is performing somehow similar to random forest, and you can see how GLM is interacting or like compared to other methods, and so on for other methods. Again, you can look at the performance of these methods and see which method is performing uh, in a better way than other methods. So this is what I want to show you today. I'll be in the next tutorials. I'll be adding more details on how to use Caret and Caret ensemble, and maybe other information that we can add for the pre-processing. Um, so thank you for watching this tutorial, and hope to see you in the next tutorial.